Today we're going to dive into some geometry. Today's lesson is section 7-1, finding areas of parallelograms and rhombuses. Under the key concept at the top of the page, it says you can decompose a parallelogram and compose a rectangle to find the area of a parallelogram or rhombus. So let's understand the key vocabulary here. The word decompose just means to take apart. So we can take apart a parallelogram, break it up into smaller two-dimensional shapes, and put them together in a different way that we compose a rectangle. Okay, so this would be putting those pieces back together, and it might be in a different way. The formula for the area of a rectangle equals length times width, so the L stands for length, the W stands for width, can be written as the formula A for area equals B for base times H for height. So area equals base times height to find the area of a parallelogram or the area of a rhombus. So let's take a look at what this all means. First diagram, we have a rectangle that has a length of 6 and it has a a width of 5 feet. The formula for area of a rectangle is length times width. So you just take the dimensions for the length and the width, plug it into the formula. We're replacing the L with the length. We're replacing the W with the actual width, 5. And then you just multiply 6 times 5, and you get area is equal to 30 feet squared. This superscripted 2, that's like a raised small 2 there, that is showing you how many dimensions you're working with. So this is a two-dimensional figure, so that's why we put the square there. It shows us how many dimensions. In the next example here, we have the same dimensions. This is a 6 by 5. However, this is a parallelogram. So a parallelogram has two opposite sides of same sized sides. And if we drop one of the vertices perpendicular to the base, we get some triangles. Okay, so if we take this triangle, remove it, and place it on the other side, so we're kind of moving it to the other side and flipping it, we get back to our original rectangle. So this just shows you how the areas are the same. This is the exact same sized shape. This one here, the parallelogram, is just tipped over. It's like tilted. Okay, so the formulas are really, really similar, except that instead of length for a rectangle, we're using B for base in a parallelogram. And instead of the width in the formula for area of a rectangle, we're going to use H for the height of a parallelogram. But it's still that sort of length, this number running left to right, multiplied by that number that's running vertically. Okay, in the next section, you understand, I will read the questions and then give you a few moments to write down the answers, and then I will discuss what it means. For the essential question, it says, how can you use the area formula of a rectangle to find the area formula of a parallelogram? And I did explain this up here, but we're going to go ahead and write down the steps. If you need a moment, you can pause the video, but if you're finished, we will continue. So it's just describing how the parallelogram can be decomposed. We can split it up, take away a triangle. You'll be left with a trapezoid. You can move that triangle to the other side, and when you push the two shapes together, you end up back with the rectangle, as we saw happen here. So we decomposed the parallelogram, we moved out the triangle to the other side, and we ended up with the exact, okay, rectangle. Okay, and all that happens when we do that is that we see that the L, the length, and the base are really the same thing. So in a rectangle, we use just length, and the parallelogram, we're using the word base. And the width from the rectangle becomes the height of the parallelogram. So it's just sort of a length times width type problem, but of course we just call it base and height in the other shape. Okay, number 2. Ken combined a triangle and a trapezoid to make a parallelogram. If the area of the triangle is 12 inches squared and the area of the trapezoid is 24 inches squared, what is the area of the parallelogram? Okay, so I drew a picture of a trapezoid. We're told that the trapezoid is 24 inches squared. That is a 2 there. And the triangle is 12 inches squared, and if you push them together, you would get a square, or I'm sorry, a rectangle, or it could be a parallelogram. Okay, so we're going to add the two parts together, the 24 and the 12, and we get the 36. Okay, and then number 3, critique reasoning. A parallelogram is 3 meters long and 7 meters high. Liam said that the parallelogram's area is greater than the area of a rectangle with the same dimensions. Is he correct? So the answer would be no. The areas of a rectangle and a parallelogram with the same dimensions will be equal, as we saw in the example all the way at the top under the key concept. Okay. Under the practice problems, I'm going to do question 4 and 5 with you, and then give you a few moments to try number 6 on your own. In all 3 of these examples, we are looking at trapezoids, and we're going to use the formula A area equals base B times the height H. When you have 2 letters side by side, these are known as variables. They are standing in for numbers. It is multiplication. So BH is B times H. Now, once we plug in the numbers, we're going to want to maybe use some parentheses around those numbers to keep them separate. So we know that it's not one long number, that it is 2 separate numbers that we're multiplying together. So the base here on a trapezoid would be where the height, the dashed line, runs perpendicular. Okay, so down here, this is the base here, the 20. And then the height is showing you where it is the line. So 21 and a half. And then you just simply multiply those 2 numbers together. We have 20 times 21 and a half, and we get 430. Don't forget your units of measure. So that would be inches, and we're in the second dimension. We're working with 2 dimensions, so we write inches squared. Okay, one more example, and then you'll try number 6. Again, we have another trapezoid. The area equals the base times the height. The base here would run where the right angle is. Okay, so this is the base. Now, the parallel lines are equal, so if this is the base would be the same as the other side. So that's 16 centimeters. And then the height would be, if we drop that vertice down to the base, the distance between. We get 12.5. And then we just multiply 12.5 times 16, and we get 200. 12.5 times 16. So we have 200 centimeters squared. Okay, so take about 2 minutes and make sure you're showing all 3 steps. Start with your formula, plug in the values you're given for your base and your height, and then your final step would be the answer. Now, while I'm sure you got 120 meters squared, we want to make sure you're plugging the numbers into the correct places in the formula. So we'll start with our formula. Area equals the base times the height. Now, think about where your base is. Your base would be down here because it runs along where the right angle is. Okay, so the base is 12, not the 10. And then the height would be where you drop a vertice down perpendicular to the base, and it forms that right angle. So the height is the 10. And when we multiply together, we get the 120 meters squared. Okay. Number 7 is a question about a rhombus. A rhombus is a special type of parallelogram. It's kind of like a square to a rectangle. So where a square is a rectangle, but a square has 4 equal sides, a rhombus is a parallelogram, and it too has 4 equal sides. This rhombus has an area of 440 meters squared. So they actually solved the A for us. We already know what the area is. We're also given the base of our rhombus is 22 meters, and we need to solve for the height. So we're going to start with the formula. A equals base times height, and we're going to fill in what we know. We know that the area is 440. We know that the base is 22. And what we don't know is the height. So you're just asking yourself, what number could we replace or substitute for this H to make this statement true? What number times 22, we're working backwards, would equal 440? So you could do some guess and check. You could try 10, you could try 15, you could try 35, and you keep narrowing it down. Or you could just work backwards and say, what is 440 divided by 22, because that will give us h. Now I'm going to kind of jump ahead here a couple of weeks into 7th grade content when we solve equations. When you divide in 7th grade, 8th grade, moving into your algebra classes, we're no longer going to use this division symbol anymore. This is really elementary division. We are now going to just use the fraction bar, okay, where you have a numerator and a denominator. And this fraction bar means to divide. So if we have 22 times h, the opposite would be divide by 22. And the 22s would cancel. 22 divided by 22 is 1h. And you could write a 1 here, and you would have your h, but that's kind of weird. You don't have to say 1h. If you see an h, there is at least one of them. So we're left with just 1. This is called the invisible 1. And if you're not quite understanding what that all means, we will go into this concept in greater detail in the weeks and months ahead. But please remember what we learned during that first full week of school. I said what you do to one side, you have to do to the other side in algebra, okay? We talked about fractions simplifying the top and the bottom. Here in an equation, we have a left side and a right side with an equal sign in the middle. So there are two sides. Well, if we divide the right-hand side by 22, we need to divide the left-hand side by 22 as well. So that's sort of the long-winded explanation for solving this. Many of you just recognized right away that instead of multiplying and getting check, you would just divide the two numbers quickly, and you would get 20. But since I need you to get there by the middle of 7th grade, I just wanted to use this time to start putting it in your heads what you need to do and what that's going to look like. Okay, this ends the video notes for section 7-1. The next activity we will work on is the practice for this skill. Have a great day.